increases the file size, but hey, what do I care? I've got plenty of disk space. Remember, memory is cheaper. All right, so let's go ahead and I will make a new class. New class. And that class is, I'm going to call it fib example. All right, so the Fibonacci sequence is fairly straightforward as far as sequences are concerned. It starts out as follows, or at least the way we are going to start it out is as follows, PSVM. Okay, it starts out like this: 1, 1, 2, 3, 5, 8. So the next number in the Fibonacci sequence is equal to the sum of the previous two numbers. So the next number is equal to the sum of 5 and 8, which will be 13. The sum of the next number will be 21, as it's the sum of those two numbers. So it's just, you generate it yourself. Mathematically, it's a fairly stable solution, or fairly easy expression to write. We say like fib of n, the nth Fibonacci number, is equal to, and I'm probably going to butcher the mathematical notation here, is equal to 1 if n is 1 or 2. So in other words, if we're at the first or second Fibonacci number, we have 1.
Isn't it 0 or 1?
It really depends on who you ask. I'm going to go with the first two Fibonacci numbers are 1 and 1. And I'm also going with the first Fibonacci number and the second Fibonacci number, not fib of 0,
Okay.
right? The second Fibonacci number is, so otherwise fib of n is equal to fib of n minus 1 fib plus fib of n minus 2. Okay? That's the Fibonacci sequence right there. 1, 1, 2, 3, 5, 8, 13, 21. And then it keeps going on until it just gets bigger and bigger, right? So the next one in the sequence would be 34. Okay? So the first two numbers in the sequence it starts with 1 and 1, and then every other number after 1 and 1 is equal to the sum of the previous two numbers. So this is obviously a recursive definition, right? We have our base case right over here. If n is equal to 1 or 2, we return 1. Otherwise, we return fib of n minus 1 plus fib of n minus 2. And we use this one as basically the first example. It's almost always taught at the same time that factorial was taught, because it's very easy to understand, right? So our in-class assignment for today, the first part of it, and I'm going to give you like 5 or 10 minutes to do this, right? And you're going to turn in your work, by the way, okay, for this. So what you're going to do is that you are going to, first part of this, write this as a recursive method. So just write this recursive method. So do so right now. Basically, write this as a method. Okay, and I'll get you started with the header, right? Public.
You're going to want to turn this in, like upload it?
Yeah, upload it. There's an in-class exercise Fibonacci here. First part of this, and you can work with somebody else on this if you really need to, but public static int fib of int n, right? So you'll need to return something, and I'm just gonna, I'll fill it out when you guys are sufficiently done with it. But go ahead and take a couple minutes to do it yourself.